You probably think the sun is the ultimate flamethrower. Big, bright, burny. But what if I told you the sun isn't even the hottest thing out there? Buckle up, because we're about to explore 5 things that are literally hotter than the surface, and sometimes even the core of our friendly neighborhood star. Before we dive in, let's get something straight. Heat and temperature are not the same thing. They're like cousins, related but not identical. Heat is energy. Specifically, it's the transfer of energy from one thing to another, like when your coffee cools down or your seat warms up after you sit on it. Temperature is how fast the particles in something are jiggling. Faster jiggle equals higher temperature. And here's a mind bender. You can have a tiny thing with a high temperature but not much heat, like a spark. Or a huge thing with a lower temperature but loads of heat, like the ocean. So what's the coldest possible temperature? Absolute zero. That's minus 273 degrees Celsius or 0 Kelvin. At that point, atoms stop moving. Literally. It's the ultimate chill, and it's physically impossible to go colder. Even in deep space, it never quite reaches absolute zero, thanks to leftover radiation from the Big Bang. What's the hottest possible temperature? Well, there's no theoretical maximum. Atoms can keep gaining energy, smashing harder, moving faster. The limit doesn't really exist. So before we look at 5 things hotter than the sun, just how hot is the sun exactly? The surface of the sun? Around 5,500 degrees Celsius. That's about the same as the tip of a welding torch, 3 times hotter than lava, which is around 1,200 degrees Celsius, 3 times hotter than a cremation furnace. And the core of the sun? A toasty 15 million degrees Celsius. That's over 2,700 times hotter than the surface of the sun. So hot that atoms can't stay whole. They're stripped into bare nuclei and electrons. You'd need over 1 million industrial furnaces stacked together to reach that. Number 1. Lightning bolts that flash a brilliance during a thunderstorm? It's not just dramatic, it's devastatingly hot. A single bolt of lightning can hit temperatures of up to 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun. Lightning forms when static electricity builds up in storm clouds due to friction between rising and falling air. When the electrical potential gets high enough, it discharges, creating a blinding flash and an ear-splitting thunderclap. There are different types of lightning. Cloud to ground, the classic strike. Intracloud, within the same cloud. Cloud to cloud, arcing between clouds. Ball lightning, rare and spooky. Heat lightning, distant, silent. And where can you find the most lightning on Earth? Lake Maracaibo in Venezuela holds the record with over 250 lightning flashes per square kilometre each year. Oh, and the person struck by lightning the most? That's Roy Sullivan, a US park ranger, hit 7 times and lived to tell the tale. Number 2. The Large Hadron Collider. Beneath the Swiss-French border lies the Large Hadron Collider, a 27-kilometre ring of pure science magic. In 2012, CERN scientists collided lead ions together and briefly recreated the conditions just after the Big Bang, reaching over 5.5 trillion degrees Celsius. That's over 360,000 times hotter than the sun's core. The outcome? Discovery of the Higgs boson, aka the God particle. It helped explain how particles get mass. The LHC cost almost $5 billion and is operated by CERN, the European Organisation for Nuclear Research. It involves over 23 countries and thousands of scientists. Basically, it's the ultimate group project and the smartest one in human history. The LHC also contains some of the coldest places in the universe. Its superconducting magnets are chilled to minus 271.3 degrees Celsius, 1.9 Kelvin, colder than deep space. Speaking of temperature, here's a quick history lesson. Temperature scale. In the 1590s, Galileo Galilei invented the thermoscope. It used a glass tube with water or alcohol, and air pressure pushed the liquid up or down. It could compare hot and cold, but not measure it in degrees. It had no scale, just more or less hot. But in 1612, Santorio was the first person to add a scale to a thermoscope. He was a Venetian physician and Galileo's friend. He marked divisions on the stem to measure change and used it to monitor patient temperatures, like a very early clinical thermometer. Back to our list. Number 3. Supernova explosions. Stars don't die quietly. They go out with an explosion. A supernova occurs when a massive star collapses, triggering a shockwave and an explosion that can reach billions of degrees Celsius. But there are actually multiple temperatures involved in a supernova, depending on what part and what moment you're talking about. A typical core temperature during collapse and bounce of a Type 2 supernova can reach 3 to 10 billion degrees Celsius, so more than 200 times hotter than the Sun. But some models suggest temperatures in localized regions can spike to 100 billion degrees Celsius during the microseconds after the collapse of the star, when densities exceed nuclear matter and the shockwave forms. This is not the whole star. It's an extremely dense core region, and it only lasts fractions of a second. Supernova events spread heavy elements like iron, gold, and uranium into the cosmos, elements essential to life. The last supernova visible to the naked eye? That was SN 1987A, spotted in 1987 in the Large Magellanic Cloud. It was the brightest supernova seen from Earth since Kepler's supernova in 1604, number 4. Z-Machine Plasma, Sandia National Labs, USA. The Z-Machine in New Mexico holds the record for producing man-made plasma at 2 billion degrees Celsius. Originally developed to test materials for nuclear weapons, it now explores fusion science and extreme physics. The Z-Machine uses powerful electrical pulses to create magnetic pressure that compresses plasma. At its peak, it consumes over 80 trillion watts of electricity, more than the entire US energy grid for an instant. So why don't we use these super hot things as an energy source? Because they're either too short-lived, lasting only microseconds, or too dangerous, causing explosions or radiation, or too hard to contain, having plasma that melts everything. We also don't yet have materials that can survive that level of heat, or machines that can hold it long enough to do anything useful. Number 5. Experimental fusion reactors. Fusion reactors like EAST, China, and JET, UK, aim to recreate the Sun's core. Fusion combines hydrogen atoms into helium, releasing this immense energy without greenhouse gases or radioactive waste. EAST has reached 160 million degrees Celsius, and JET recently held plasma for 5 seconds, a record. The long-term goal? Sustainable clean power from nuclear fusion. Unlike fission, splitting atoms, fusion is safer and cleaner. But it requires crazy temperatures and magnetic fields to control the plasma. If we can crack it, fusion might power the future. If not, well, it'll still be the hottest science experiment ever, so there you have it. 5 things that make the Sun look like a warm cup of tea. From supernovas to particle smashes, the universe, and even human science, can turn up the heat way past solar levels. But the Sun still wins at reliability. Every morning, right on schedule, with just enough heat to toast your bagel. Enjoyed the burn? Then smash that like button before it cools down. Subscribe to Fact Drop 5 for more weird, wonderful, and wait, what? Facts, served in 5s, because that's how we roll. See you next time, and don't forget your sunscreen. Just in case.